Well, my name's Scott. I'm living in Wisconsin right now. For those in Europe, that's north of Chicago. I work at Audit Board and with a bunch of great folks. And obviously, I got a baby hanging out with me right now. So that's my that's that's a little bit about me. Chris, you want to go?
Sure, I'm Chris. You mostly probably know me as Runspired. I've been working on Ember Data for about 5 years now, maybe a little bit longer. It's been a while. Uh, so been on the core team for most of that time. Been pretty excited that we brought Scott in about, when was that? About a year and a half ago,
Something like
officially.
that. Yeah. Yep.
So I was pretty excited to rope Scott into doing things. Right now, I'm working at a company called Graphql with Ember, and we're using Ember Data. So that's about it.
Good, great. Thanks, guys, and thanks for doing this, and thanks for taking the time to taking questions from the attendees here. So I would say let's start with the first question. Anyone here or on Zoom?
What's the vision, roadmap, and the future of Ember Data look like?
I think that's a very open-ended question right now. We're in kind of an interesting time for the data team. We've had a lot of turnover in our team membership this year. A number of folks, for various reasons, just found themselves overcommitted, decided it was time to take a step back. And so the team has shrunk. It's actually shrunk all the way down to Scott and I, and we're not sure yet if David is still capable of participating. He's been quite busy as well. So we are definitely entering a bit of a rebuilding phase on the team, which means that we have less availability to go and implement the things that are in our vision for what the horizon of Ember Data should be. That said, it's also a really interesting time because the world's kind of our oyster in a way that has not been true for this project historically. For many years, Ember Data was very tightly coupled to Ember's object model, very much constrained by its change notification system. And that really limited not only our ability to make progress on APIs and ergonomics, but it really weighed us down in terms of bug fixes in between releases, especially at the end of the 3.x cycle. Once tracked properties had been introduced, we were then having to support the tracked notification system on top of the legacy notification system, both in synchronous and asynchronous modes, which was not an easy thing to do. And there was a lot of rough things that happened because of that, where things would break or we'd try to make a change and just couldn't support all the things. And we would have to iterate it on a whole bunch of times until we figured out all the things that we had to do to make it work. But what's great is that with Ember 4.0, two changes have happened. One is that synchronous observers are gone, which takes the hardest part of the old object model and gets rid of it in terms of what we had to support. The other is that IE11 support is gone, which means that now we can use native proxies. And so everywhere where we've needed a proxy historically could be a native proxy, which would improve the ergonomics. But more importantly, it means that a lot of APIs that we didn't have a mechanism for deprecating very easily in the past, because there wasn't a clear way of switching between the old API and the new API without a proxy, could now be deprecated. So we have a lot more ability to iterate because of the 4.0 change than was there in the past. We're also at a really interesting place because for several years we focused on rationalizing the internals of Ember Data and rationalizing the relationships between the different packages that Ember Data provides. And so today, you don't have to use all of Ember Data. You could choose to just use Ember Data Store and bring your own adapters, bring your own serializers, bring your own cache, bring your own model. You don't have to use the whole Ember Data experience. You can pick and choose which parts make sense and compose them with other parts. We did that so that we could both explore what the future should be like ourselves more easily, but we also did that to enable add-ons to explore that world for us. So far, there's really only been one add-on that has explored that world, and that's Ember M3. And it provides a custom cache alongside a custom model implementation, which is a really interesting path forward because Ember M3 solves two problems out of the box that a lot of people have. One is change tracking of relationships and rollback of relationships. And the other is deeply nested attributes or complex attributes, which is a problem that historically people have leaned on model fragments for, in which model fragments historically has used a lot of private API to support. M3, on the other hand, is built entirely over public APIs. So it really showed that our work to differentiate into the packages, define their boundaries, define their roles, had unlocked a great future. And I think we're now at a point in time where it's time to go and take the rebuilt internals and peel back that layer and introduce new public APIs. To that extent, there's really two areas of focus that for the next year, I would love to see us focus on. I think Scott's going to drive one and I'm going to drive the other. So I'll let Scott talk about the area that he's going to focus on and maybe then come back and talk about the area that I'm going to focus on.
What area am I focusing on? We don't talk that often. We talk once in a while.
The network changes.
The network.
We only talked about this last night. I mean, we've talked about it a lot. We were only talking about this last night. Short-term memory. I'm assuming there's no sleep with the baby.
It's rough. I think there's been some RFCs or documentation around that. Is that right, Chris? The network changes, are those public? I'm just curious.
So there's a combination of things that are public and things that you could do with public API and nobody's thought to do, and things that we want to do that you could do today in public API, but we would like to actually just do out of the box. So the main thing is that if you were to go into the documentation today and look at both the adapter and the serializer package, you will find documentation for a thing called the minimum adapter interface and the minimum serializer interface. These are the public interfaces between the rest of Ember Data and the adapter API and the serializer API. Absolutely everything else you've ever thought of as being related to an adapter or a serializer is specific to an individual implementation of an adapter or serializer and not part of the actual API boundary. The interfaces are rather small and a lot simpler, but we could actually make them even simpler and smaller still. And that would roughly look like you take, for instance, in the adapter, all of the find methods, and you pare them down to something like a single request method that takes in an operation that maybe has an opcode of find record or query record. And from there, you handle the request as you see fit. So this could work very well with the existing adapter API, but you could also introduce a fully new thing, which we've kind of tentatively been referring to for a couple of years as request manager. The power of this is that the trouble that people typically have with the kind of built-in adapters and serializers is that they lack context of the requests being made. You don't know what the URL being fetched was when you're normalizing or serializing your data. You don't know what the URL being fetched is when you're setting up the options for the request. If you're trying to use those hooks, it leads to a lot of frustration and banging your head against the wall. Those API designs were very flawed. But if you rebuild over the public APIs, that public contract between the store and the adapter, then you don't have that issue. And we want to just make that the default story where when you're handling a request in an adapter or a serializer, you have that full context of both what was requested and what your response is all in one place.
And I think the key word there is middleware, right?
Keyword there is definitely middleware, because a common problem that I'm seeing right now is people moving to fetch from Ajax. In Ajax, you had this great ability to use Ajax prefilter and Ajax setup, and from anywhere in your application to make sure that you'd configured your requests in your adapter to handle things like session and cookie auth and whatnot. With fetch, there isn't a natural hook for being able to widely configure those things. And the existing adapter APIs don't really have a great hook for that either. So with kind of this re-envisioned, what does the fetching layer look like story, where everything is moving through a single request method, we would be capable of setting up a middleware registration system where the middleware could take the request, look at it, and determine what headers and whatnot to add into the options that are going to be passed to fetch. And so you would be configuring a middleware that would handle that instead of trying to call Ajax setup or Ajax prefilter. That sort of a thing.
And some of the work maybe in between today and then is I'm looking into how to make the existing adapters fetch compatible. I think right now Ajax is overloaded and then it switches on a fetch or an Ajax. And I think a lot of people override the Ajax methods on their adapters. And so making a public API sort of with fetch may be an intermediate step to get there.
It's certainly the case that we don't want to just wholesale introduce the new world. I think that's what has held us back in the past, was that we didn't necessarily know exactly what the new world would look like. And we were hesitant to make changes to the current APIs without knowing where we were going to with the finalized version. But because we now have this ability to wholesale swap out components, like completely swap out the adapter layer and whatnot, it unlocks the ability for us to provide a new world that's opt-in, that's not necessarily a required transition, and maintain the old world for a very long time without the costs being paid by consuming applications. Because if you don't want the old world, you just don't have the package in your package.json. The great thing with that, though, or the problem that we have with that is exactly around this stuff like Ajax setup, Ajax prefilter, all that kind of thing. Right now, it would be very difficult for most applications to seamlessly swap from whatever adapter and customization they've done in that adapter that they have over to the new world, in large part because there maybe is not a clean transition. I mean, one way to think about it is a bit like you're relying on spaghetti jQuery code throughout your application and then trying to swap out your DOM rendering engine and expecting it to just work. It doesn't work like that. If you've been setting up and configuring Ajax with spooky action at a distance methodologies, then it's not going to be a pleasant transition from something that uses Ajax to something that uses fetch. So we really want to take the existing adapters and iterate on their APIs a bit, remove some of the Ajax terminology, really push people into the fetch world and make sure that those hooks are there even in the old adapters, so that at least those concepts are aligned, and then the transition from that old world into the new world is much more seamless.
That was a good answer. We have a couple of questions from the Zoom chat now. So you kind of touched on this, Chris, when you mentioned M3. Are dirty, clean relationships ever going to be a thing?
I think the short answer to that is I'm not sure, and the long answer to that is I want them to be. The big trouble with dirty, clean relationships is simply what it means different things to different people. If what we're talking about is constrained to simply the membership of the relationship, meaning I don't care that your user has a friend model and the friend's name has changed. That doesn't make me dirty. What I care about is that you've swapped out one friend for another friend in the relationship. That makes me dirty. The membership as the relationship has changed. If all we were referring to is membership changes, then I would have to say that the future is very close. We have the infrastructure underneath the hood to do this now in a way that we didn't before. We rewrote the relationship layer in 3.2.8. It's much more rationalized. It's entirely built over identifiers. It's handled by membership, and it stores itself as a diff. So currently, we store our membership by what the server has told us, and then any local additions and removals that you've made to that. So it's actually stored in the diff state, and then we lazily calculate out the final state of what needs to be shown in the UI from that. So I foresee a future in which a different relationship accessor off of model gives you direct access to that diff and the ability to roll it back very cheaply. I think one reason why we haven't necessarily leaped to do that is there's also this question of, do we even want to expose the concept of dirty and clean state in the future from the store? If you're familiar with Ember Orbit or Orbit.js, you'll know that you don't really have a concept of dirty state. You have a concept of a forked store. And if you decide that you make changes against the fork, and if you decide that you don't want those changes anymore, you discard the fork. This lets you much more safely operate across a lot of records at once in terms of making changes, keep track of what was changed, and later either commit those changes or discard those changes. I think we are still heavily considering moving towards a dirty state goes into a fork solution, and rollback and whatnot would simply be discarding the fork and getting a new one. And you would do that across all records as part of a transaction, not just as one single record. So that's an open design question. But the really neat thing is, because we've built the APIs the way we have in terms of how things are encapsulated, this is something that can be solved in userland. It does not necessarily have to be solved by the core of Ember Data. And we can experiment with both solutions. We can experiment with a store forking solution, and we can experiment with a rollback off of the cache directly at the same time.
I've chatted to you before about using Ember Data with GraphQL. Do you recommend this, and how do I get started?
I do recommend this. The unfortunate thing is, how you get started is you implement your own cache. You don't necessarily have to implement your own cache. Actually, M3 is basically a GraphQL client for Ember Data. If you think about how it operates, with GraphQL, you traditionally do not have management of inverse relationships, which is something that M3 also does not provide. For instance, if a user has a best friend property that is one-to-one with another user's best friend property, and you remove the best friend from one user, if you've configured inverse relationships, you have inverse management, then the best friend property in the other record is also cleared. That's what I mean by inverse management. In GraphQL, you typically don't have this ability to manage inverses. Pointers go one direction only. M3 takes this approach, which is why it's so easily able to solve the relationship rollback and dirty state problem, is because since all things are one directional, it doesn't have to consider the consequences of a rollback in that regard as to how far down the chain of records it is rolling things back. So from a GraphQL perspective, M3 exists. What you would do if you want to use it with GraphQL is pretty much just come up with a convention around your GraphQL API, providing an identifier that M3 would be able to look at and determine is a key that represents identity. From the perspective of Ember Data's core logic, all we care about is that what the adapter returned is an object with a data member and an included member. Data member being the primary data, included being any other data. So you kind of have to hoist your GraphQL entities up in advance, or at least if you want to do it this way. But what the shape of that data actually is, M3 doesn't care. In its cache, it can look like anything. So as long as M3 and Ember Data are capable of determining identity of an object, which is something you can configure, as long as they're capable of determining identity of an object from those objects, you're good to go. Just takes a little work of configuring your M3 schema to work with the shape of your objects. In terms of TypeScript support for that, it's kind of similar to Ember Data support for TypeScript today. If you're using the @types Ember Data package, what you would do is you would take your schemas, you would generate types for them programmatically, or write them by hand, and then in your find record and whatnot, you're going to take those schemas, you're going to add them to the model registry, then your find record and whatnot, when you're requesting a record by that type, you're going to get the type back for that, just the same way you would do with Ember Data today using the @types packages. But that's really the easy route right now is to go with M3. I think we can do better than M3, and I think we can provide additional tooling over what M3 has. But that is the quick path to being able to do it today.
Now moving on to a question about JSON API spec. Is the core team going to maintain the JSON API spec? There are RFC style issues hanging for many years. For example, batch operations and transactions. And JSON API v1.1 was planned for release in January 2019. What's the plan for that?
We've historically been tightly coupled with the concept of JSON API from the perspective that JSON API was a standard that grew out of Ember Data years and years and years ago. And we had many members of the JSON API core team in the past who were also members of the Ember Data core team. We don't currently have any shared membership. Dan who was the last person who did, stepped away from the Ember Data team. And we don't particularly see ourselves as a JSON API library. Now, the default implementation of the cache speaks JSON API, but your cache is pluggable. It doesn't have to speak JSON API. It may not be the best standard for your particular API. So really, I don't foresee us having a need or desire to try to elevate someone into core team status for JSON API and work on those issues, because we see ourselves as a utility library that's capable of working with any standard very nicely and not one particular spec.
Using Ember Data with TypeScript is frustrating. Some types are awkward to deal with. Attributes require typecasting, which makes them prone to errors. Are there any plans to improve this?
Attributes should not require typecasting. You may have set something up wrong if that is the case. Relationships require typecasting in one situation, which is that in TypeScript, you cannot have a getter and a setter with a different type signature. And so if your type signature for if your type signature is for specifically an async belongs to, the trouble that you get into is that with an async belongs to, even though you can get it, you can't set back because TypeScript expects that you're setting a promise proxy back when you should be setting the record back. So you end up having to lie to TypeScript and do that as unknown as promise belongs to T kind of deal when you're attempting to set an async belongs to. And that's frustrating, but remember that Ember Data was written before TypeScript was a thing. I've cataloged 3 or 4 different areas today where Ember Data, were we to fully type it out, really just doesn't work with TypeScript because of API decisions that were made at various points in time that TypeScript doesn't support well. One of those is actually Async Await. So TypeScript with Async Await, it looks at it as the return type of any async function must be a promise, a native promise. It can't be a custom thenable, even though the JavaScript spec is that the return type of something async could be a custom thenable, literally anything with the then method. And so lots of places in our API, we have signatures where we are returning a custom thenable, but it's a hook that you could implement. So for instance, find record in an adapter is a hook that you could implement that's asynchronous. But if you were to extend from our types, it would throw an error if you tried to use async as the keyword, because the return type of RSVP promise is not exactly the return type of a native promise. And today ours is returning an RSVP promise. So we have a lot of work to do to really get to full TypeScript support. I think this is where I've been very hesitant about the current direction of the wider framework team and core team in regards to TypeScript. I don't think that our team currently has the manpower to go finish off the TypeScript story. And I think we have a lot of work to do to actually make that first class. And it's not clear who's going to do that work. We want to do that work. It's just not clear who's going to do it. and that work is higher, I think, than for everyone else, simply because it's not just about can we produce types or can we bring the at types Ember Data project over and build it in. It's that the at types Ember Data project was really not fully thought out for Ember Data well either. And the APIs aren't always really great for TypeScript. And so there's a kind of evolution that's going to have to happen in our JavaScript code to support TypeScript alongside that, which means I think things along the lines of abandoning the Ember object model, like not having a model that's built off of Ember object anymore, abandoning async relationships that return promise proxies in favor of something else, so that we don't have to deal with that. There was a question that was submitted in advance, like what legacy decisions are still holding Ember Data back as a project? The world's our oyster right now. We are in a really good place to where we can change, but I think if there's two things I point at that still really slow down the pace of that change until we get the whole path forward, it's that model is built off of Ember object and that async relationships are a thing. I think we want to replace both of those concepts with something new. When I said earlier that there's kind of two main areas of focus, one that Scott's going to lead, which is network stuff. When I'm going to lead, the area of focus that I'm going into is actually exactly that. It's how are we going to replace Ember Data model? What are we going to replace it with? M3 really paved the path for us on that in terms of what would a nicer story for model look like? What concerns could it handle? I don't think it's the answer for us because, for instance, it doesn't do inverse management, and I think it is a little bit heavier handed in some areas than we need. Like, I think we can go a little bit lighter, more ergonomic, and I think we can make the transition story really nice. So I'm going to attempt to screen share here and show the sketch of what we think the evolution of model is going to be. And so today, this is what you have. And I've intentionally chosen classic syntax here because even in a modernized Octane world, using the classic syntax for models has turned out to have its advantages if you care about performance. Because it turns out that decorators are a huge bottleneck for class instances, and models are generated often enough and in high enough quantities that bottleneck can become very apparent in some apps. So some apps have stuck with this versus converting to native class. But to get into the new world, you're going to have to convert to native class. And so the first step that your application would do would be to come in here and modernize this. And so you will come up with, class extends model. And we will change all these over to adder. And there's only two of these. And I've left myself a few notes here, which we'll talk about as we do this. So for instance, age here is a date, which is a transform. Address here is actually a complex object, which you can use in Ember Data today, but means you don't get change tracking on the sub-properties. And this is where typically people reach for model fragments or M3. We have these relationships, and so we modernize those. And once we'd gotten over to being in a native class, which I probably should have just had something like copy paste here in the beginning, but I wasn't that smart. And this is going to yell at me because I had this as a TypeScript doc, but I don't actually have any types imported or configured, and we're not declaring anything. So that's what some of this yelling is. Almost here. All right, so once you've modernized it, the migration path that we're sketching out is going to look a little bit like this. You get to keep this model exactly as is today with everything that is in it and piecemeal migrate to a world that doesn't have model in it at all. The way this is going to work is we're going to write some new decorators, and you would import something like, say, resource attribute, resource, and collection from Ember Data. Man, I cannot type. At Ember Data schema. And this would work alongside your existing model definition. So as long as it's a native class and not the old classic syntax, you'd be able to import these and begin using them. So you could say that, hey, for addr name, since it's not using a transform, I can just go ahead and say that this is an attribute. For address, I can say the same thing. And the moment you do this, you've now opted into change tracking on address and deeply nested objects. We would be capable of doing that. The next thing that you would do is you'd say, oh, I have all these relationships. What do I need to do for them? The easiest ones to deal with are going to be the ones that are async false, because those will have a pretty clear one-to-one mapping into the new world. And so you just come in here and you'd say, instead, this is a resource, and I no longer need the async flag. But resource, the difference with these relationships is probably that it's going to be an object that has both like a fetch method on it and like the meta, the links, and a data attribute. So if you think about it from a JSON API perspective, it's that little extra document, smaller document that has this extra information. What this allows us to do is easily paginate things if it's an array. And it allows us to allow a relationship to operate both synchronously and asynchronously. So if you wanted to synchronously access data that has already been loaded for this relationship, you could just do bestFriend.data in your template or in your JS code. If you still needed to fetch it, you could either await bestFriend. Execute the fetch, passing any options that you needed to pass in, and you could write a template helper that basically does that and awaits in your template as well if you wanted to make sure that something was loaded in the template. So what's cool here is we could go do the migration for bestFriend and have not migrated none of the rest of our code in this model yet. But as we go through one thing at a time and move it over to the new world, same, with each one of these things, and maybe we migrate for the age migration for date, for instance, we probably would have to go in and make it just be a string all the time. And then once we had done that, we could do it as an attribute. Once we've done this, where we've gone one thing at a time, getting rid of all of the things, then resource, and then we have this is collection again, and this is collection, and this is collection, and here we go. So once we've gone through and done this, the next step is, well, you don't need any of these anymore. And since we're no longer needing any of the model infrastructure, since we're no longer using addr belongs to and has many, you just drop this part. You don't actually extend from anything. Now, if you wanted to still extend from a base class, or you wanted to still extend from Ember object for other reasons, or you wanted to be able to inject stuff from the container, you could extend from Ember object and use injections and do that if you so desired. But you wouldn't be required to. If you wanted to, you could literally just export a class that has only these decorators on it. What's really powerful about this is we can go from this and compile it down into a very small schema string. Ember Data already has a schema service that's public API. We could register those schemas via, we basically just store them in JSON output as part of your build. we registered those schemas with the schema service, and you don't need this class anymore at all at that point. At that point, we can look at this and say, actually, we don't need to ship a class for you, period. Which takes a big expensive thing in your build and just deletes it. So this is what the full M3 story looks like, where you would ship any schema that you need to ship out of band, and you don't have model classes at all. So you've iterated your way from being on a model to being on effectively something like M3, except that your schema still allows you to have inverse relationships when needed. What's really nice here is that, let's say that you have 90% of your models that works for, but here and there you decide, hey, for this particular model, like let's say for user, I have a first name attribute and a last name attribute. So first name, and I want last name, and I want to do the whole get full name, return this, that first name, plus some space, and this, that last name. Let's say you wanted to do that you wanted to put state on your models, which for the record, not a huge fan of, but everybody makes their own application decisions. And sometimes this is a pattern that works really well. Sometimes this is the pattern that you want, is to have computational derived state on your models. Well, we're not going to restrict you from doing that. If you continue to implement a user class, we can still compile the schema out, remove everything that's related to the schema from the model to make it as small as possible, and leave behind just your derived state. And so when you instantiated the record, you would be instantiating a thing that would still have access to the derived state. For that, you would probably need to still be extending a base class, which you would also be importing from schema if you wanted to, or some other thing as desired. The reason that this could work so well is a secret hidden thing that resource and collection and attribute are doing, which is that there are public APIs that are available today where you can say, hey, for a given model instance, e.g. any object instantiated by the store, which is a user configurable hook, is an instantiate record is a user configurable public API hook. But any object that was instantiated by that hook is weak mapped to its identifier. And so there's a helper that you can import from the store. It's record identifier 4. You call record identifier 4 on that model instance. It gives you access to the identifier. You can call, but once you have that identifier, this helper can then take that identifier, get the store instance, get the cache instance, and query that cache for information about itself. So this resource decorator, it knows that its key is best friend. It knows that it's in the user model. It knows what its inverse is. It knows what the typing is you need to access. And so it actually has, in a self-contained way, regardless of what class you put it on, you could put it on any class you wanted. In a self-contained way, it has full access to the ability to go get what it needs out of the cache on its own, no record implementation needed at all. Like in theory, you could export default a raw object here and not even a class, and it would work. So because it's self-contained in that way, these decorators that we would provide from schema, they would be capable of working with literally any implementation out there. Or if you just decided you didn't want them, you want to do something like M3, it would just work. Right? You don't have to include the schema package. This gives us a really nice way to transition from an old world to a new world.
Awesome, great. Like, I guess like everybody can't wait to get rid of like Ember object in Ember Data and so on. I think we're kind of out of time now. I would just like to ask one last question. And you said you had changes in the team, and essentially now it's basically just the two of you, and you don't have the manpower to do many of the things that you would like to do, right? So is there any way for people to get involved without having to dig deep into the internals of Ember Data, which would probably be like a pretty high barrier for most people to cross? Do you have any plans for providing, I don't know, guidance, having quest issues where people can sort of, with relatively little time, maybe, and not a requirement of like learning all of Ember Data, sort of be helpful?
I think some of this work is capable of being done with specialized knowledge of at least one part of the system, which is itself a big barrier. And I think this has historically been a problem for Ember Data, that a lot of the problem space that it takes on and tackles is highly complex.
Yeah.
And I know the biggest thing for me as I was ramping into Ember Data was not what the code was doing. I can read code and figure out what the code is doing. It's what the code wasn't telling me. And TypeScript has helped out with that some, and proof testing has helped with that some. But mostly there was just a lot of context to be gained around problems generally. There's a lot of very classical computational problems that Ember Data has to solve in order to do what it does, some of which are classically famous for not having an answer. And so what the code is trying to do is give it the best guess 90% of the time, and we've got to figure out how to let you reject the rest of the time. Learning all of that context, like, oh, the reason we can't do relationships the way everybody wants us to do relationships is it's actually a two generals problem. Like, we don't actually know. We don't have any possible way of knowing enough context to know the right thing to do. Which is, look it up on Wikipedia if you're curious what the two generals problem is. But it's an information systems problem. It's a very classical, fundamental information systems problem. Learning that kind of context took a while. And I don't see a way around that for a lot of folks. That said, I am always happy to pair with folks and go as deep as you want and spend as much time as you want. I will be making my best attempt to put some of this stuff into Quest issues, especially I think the TypeScript stuff is going to end up being in Quest issues. I think one of the most important things for Scott and I is getting the IRC design work done so that somebody who is interested could step up and work on those implementations. But right now, it's if you have an interest in joining the data team, we have openings, and like just be prepared to be very confused for like 6 months as you're learning stuff, and then suddenly have some insight and knowledge and go, oh, okay, this makes sense now.
Yeah, like that's maybe something that everybody should be considering. And I guess like improving Ember Data is probably a super high leverage work for the Ember community, because Ember Data is probably one of the biggest pain points for many people working with Ember, right? In particular, where it holds you back, sort of from like dropping like Ember object, and where you still have to use get set and so on, right? So I think everybody should be considering helping them, and if they offer to pair and so on, that's awesome.
But I guess related to that, thank you, Scott and Chris, for the time you do put into it, because it must be tough just being the two of you. So like everyone here appreciates it, and thank you for the time and for spending the time with us tonight.